In this video here, we're going to look at two routine things that you're asked to do with straight lines at National 5. We're going to look at rearranging our equations, and we're going to look at finding points of intersection. On this page, we're going to concentrate on finding the gradient and y-intercept of our following equations. The first three are fairly straightforward. The first question, I've got y equals 3x plus 4. So we should hopefully know already that the gradient is 3. We get the gradient from the coefficient of x, whatever x is being multiplied by. Our y-intercept is at 0, 4. And again, I can just pull that out from the constant on the end of my equation there. Think about what that would look like. I'm going to sketch each of these lines. I've got an x and y axis. My y-intercept of 4, or rather 0, 4, is a point 4 up the y-axis there. The gradient of 3 means it has a positive gradient. So I would have an upward slope like that. B, the gradient, this time, is 3 again, because my coefficient of x, the number in front of my x term, has not changed. So my line is going to be just as steep as the one in the first one. My y-intercept is going to be at negative 4 this time. So it is the coordinate 0, negative 4. Again, if I were to sketch that, I would have a set of axes, x, y. The y-intercept is the point 0, minus 4. So it means this line crosses my y-axis at negative 4. Positive 3 for my gradient, so again I have an uphill slope. Next one, C. My gradient in this case is the coefficient of x. So x has moved to be the second term here. I've got negative x. So what I've got is I've got an implied 1. I've got negative 1 lot of x. But you'll never see that 1 written down. So I have got a gradient of negative 1. My y-intercept is at, well, this 6 is the constant, the number on its own. So that means my y-intercept is at 0, 6. To sketch this, so again, x and y axis, my y-intercept is going to be at the point 6 on the y-axis. I have a gradient of negative 1, so a negative gradient is going to go downwards like that. We are able to pull the gradient and y-intercept out really easily when y is the subject, like it was in the first three here. The next three, y is not the subject, so we need to do a little bit of work with these three here to get the y on its own. So to get y on its own here, I need to get rid of a positive x. So to do that, I'm going to subtract an x from each side. And I'm going to be left with a positive y equals, I can write this as 3 minus x. I've got a gradient of negative 1 because my coefficient of x is negative 1. My y-intercept is at 0, positive 3 because this term on its own is positive 3. So again, if I were to sketch that, it looked very similar to C. It would cross the y-axis at a point 3 up, and because it's a negative gradient, it would go downhill like that. E. I've got everything lumped over to the left-hand side, so I've got x's, y's, and numbers. I'm going to leave the 5y where it is and get these numbers over to the other side. If I subtract 2x from each side, 2x minus 2x on the left, that'll cancel cancel out, leaving me with 5y minus 10, and that'll be equal to, it's going to give me negative 2x. I've got my y term, but I've got this negative 10. So I'm going to plus 10 to each side. That'll leave me with 5y, and I'll have negative 2x plus 10. I don't want 5y, I want y to be the subject, a single y. So I divide through the whole equation by 5. That tells me a single y will be equal negative 2 divided by 5, doesn't go, so I just leave that as negative 2 over 5x. 10 divided by 5 will give me 2. So I have got a gradient of negative 2/5, because that is the coefficient of my x term. The 2 is on its own, so my y-intercept is at along 0 up 2. Now, if I were to sketch that just quickly, xy, 0, 2 is going to be the point 2 up. Negative 2/5, again, is going to be a downward slope. Because 2/5 is less than 1, I've tried to draw a fairly gentle slope there, so it's not a very steep hill. Last one. What I've noticed with the last one is I've got negative 8y. So what I'm going to do is I'm going to try and make this positive to begin with. So I'm going to start by plussing 8y to each side of my equation. That'll leave me with a 12 on the left-hand side, and it'll leave me with 10x positive 8y. I haven't got the y on its own. Here, there were two terms, one of them being the y. I've still got two terms with one of them being the y, but I'm avoiding this little negative symbol. I'm going to get rid of the 10x, so I will minus 10x from each side. So that'll give me 12 minus 10x on the left equals 10x minus 10x, gives me no x's on the right. And it'll leave me with an 8y. I'm going to divide everything by 8, so I get a single y on its own. So the right hand side will become y, and I'm moving it over to the left. 12 divided by 8. Right, that doesn't go, but we can simplify this fraction. I can divide the top and bottom here by 4 to give me 3 over 2. Minus 10 over 8, well 8 doesn't go into 10 exactly, but I can still simplify this fraction by dividing the top and bottom by 2, and that'll give me 5 over 4x. So my gradient is negative 5 over 4. The coefficient, what I've multiplied x by, is negative 5 over 4. And my y-intercept, in this case, I've got a fraction, but that's okay. It's along 0 up 3 over 2, or 1.5 if you will. So again, sketch to this will look similar to the one before. I've got a positive y-intercept at the point 3 over 2, and I've got a negative slope, so a downhill slope, like that. The other routine thing we'll cover in this video is finding points of intersection. To find the point of intersection between two lines, you've got a number of things you can do. The easiest thing, really, the most straightforward thing, is to treat it as a system of simultaneous equations. So here I have got an equation of a line, and I've got an equation of another line. I'm going to set them up as a system of equations, and I'm going to solve for x and y. So I need to be careful here. My first equation is 3y minus 2x equals negative 9. My second equation is formatted slightly differently. When you're solving simultaneous equations, it's often useful to have your x's and y's and your numbers all lining up nicely. So I have y and x here, but I've got x and y here. So I'm just going to rearrange this. I've got negative 12y, positive 7x equals 24. Now, there are a number of things I could do here. I could try and make the x's match up, positive, negative. So if I made these match up, I could add the two equations together. However, I've got the same situation here. I've got negative 12y, positive 3y. If I make these two match up, I could also add. It makes more sense to eliminate the y's because I've got to do a little bit less work to get the y's to match up. If I take equation 1 and times it by 4, I'm going to get this. I'll get a new equation, equation 3, and I will get 12y. Multiplying this by 4 will give me 12y. I need to multiply this by 4, negative 8x. I need to multiply this by 4, negative 36. And if I look carefully, equations 2 and 3 have got the same amount of y's, only with different symbols. So I am going to go ahead and I am going to take equation 2 and I'm going to add it to equation 3. And what that will give me, negative 12 plus 12. That's what we call a zero pair in maths. These two things will add together to give me nothing, to give me no y's. 7 add negative 8 will give me negative 1, so negative x, equals 24 add negative 36. So I can think of this as 24 minus 36. Well, that's going to be a difference of 12, so negative 12 there. If negative x is negative 12, positive x is positive 12. Really what I've done there is I've divided each side by negative 1. So I've got one of my values. I know what x is. I now want to find y. So I can substitute x equals 12 into any of the equations I've got here. Because the numbers are slightly smaller here, I'm going to use 1. So I know 3y minus 2x has to equal negative 9. 3y minus 2 12s equals negative 9. So I've substituted x for the value of 12. 3y minus 24 equals negative 9. I've got a very standard equation here. I want to figure out what y is. So I'm going to add 24 to each side. So that'll leave me with 3y on the left equals, I've got positive 24 minus 9. So adding them together will give me 15. So a single y will equal 5. Now, I need to make sure I actually answer the question, find where the lines with the given equations intersect. So I need to just take this a step further and interpret my answers as a point. My point, excuse my handwriting, of intersection. Now remember, a point is described by x and y coordinates in that order. So x is 12, y is 5. So if I were to graph these two lines, they would cross over at that point there.